Hello everyone, this video is part of the submission for Bitcoin Hackathon Algorand Greenhouse hack number 1. This Greenhouse hack is about code that Algorand dev team built and open sourced, often 2 of 3 multi-signature deployment of transactions to Algorand blockchain. The goal of this hack is to implement an M of M multi-signature transaction deployment to improve user interface and to fix some security issues. I will first describe briefly the design flow behind the application. Then I will demonstrate setup for the demo, and finally I will make a small conclusion about what work has been done. Now I will explain the design flow of the application. First, we need to generate a raw transaction unsigned. Let's say we have 2 users, it can be more. They share between them addresses, for example A1, A2, A3 for user A, and B1, B2, B3, B4, whatever for user B. These addresses are put together in a multi-sign address, which requires MSIG parameters, which consists of a version, a threshold, and a signer size. The threshold is the M of n. This means that with M signatures from these n addresses, the transaction is valid and will be broadcasted to the blockchain. Then with this multi-sign address, user A or B, let's say user A, generates a raw transaction of an asset. For example, the asset can be a payment or an FT or any kind of Algorand assets from Algorand blockchain. He then sends this raw transaction encoded base 64 to the server side. Along this raw transaction, multi-sign parameters are sent to the server side. Since raw transaction doesn't include MSIG parameters, you will need these parameters to perform step 2. Step 2. We need to sign this raw transaction. Signer A, user A, and signer B, user B, queries the server side for a raw transaction and MSIG parameters. With these parameters, they can sign the raw transaction. For example, user A signs to sign transaction A1, A2, A3, and user B, B1, B2, B3. Then they send to the server this signed transaction, also encoded by 64. And right now the server has a raw transaction and some signed transactions, which leads to the last step, broadcasting the assigned transaction. Once the signer threshold condition is met, the server merges all transactions to a one signed transaction that it broadcasts to the blockchain. The blockchain validates the signed transaction. It can fail or it can be broadcasted correctly and validated. Once this is done, the server side gives users, user A and user B, a network transaction ID that they can see in GoldSeeker, for example, from the blockchain, and see that the asset was correctly signed, the payment was correctly made from the multi-sign address to the destination address, or the NFT was minted. Very well, this ends the design flow part. Now I will explain how to set up this project. First, we clone the GitHub repo. I've already done that, so it gives me an error, but that's fine. It's just not to wait for the repo to clone. We cd first to the backend. So cd I was saying multisig and backend. Okay, we're in the backend, and the backend is a Go program, so please be sure you have Go installed in your box. I run Go 18. You can run Go 17 if 1.17 if you want. We will get dependencies by running go mod td. It will be very quick in my installation because I've already done that. In your computer it may be a little slower. And once this is done, no more to wait, go run, and it's in the directory cmd main.go. You can run directly inside cmd. The directory structure will be a little different, but it will work too. We wait a little, and don't forget in Windows to allow access to the network. Once that is done, you have access to your server in port 1881. I will just show you the Swagger UE API docs, and here you can see documentation of all endpoints that is at your disposition. Some are useful for you or none. Okay, next step. Since we have this front end, you can see we have some information. If you wait 1 minute or more, you will see the cron job triggering, and we will see that no transaction are to be signed. It's fine. I will now let it run. I will clear the terminal. Next, we need to go to the front end. Fine. It's a React app, so pretty basic stuff. npm e or install to install dependencies. This will take a little while. Maybe I will cut it in the video, but it should not take too much. Okay, done. We have all dependencies, so cool. Once this is done, you can run npm start to start the local server for your React app. It may take a little longer, not too much I hope. Okay, this is done, no errors emitted, and we are presented to the landing pages which requires you to connect to your wallet. I will not touch that right now, so I will clear it. Next and last thing to program to set up is the Argo script. Okay, Argo script is just a Node.js application, so npm e to install dependencies, fine. And here we can ls, and there are two things that are important. First, index, which you should not use from my repo because everything is done in browser, and the generate icons, which can be useful when you want to generate 5, 6, 7, 8 accounts to test m of n applications. Next, a little demo. Okay, now I will make a little demo of the application. First of all, you need to have, oh, excuse me for my avatar, you need to have the Algo Signer app extension, Chrome extension, or Firefox, or whatever your browser is installed. And with some accounts on the testnet. I've already done that. Test 1, test 2, test 5. Okay, we'll see that in a second. Some have more algos in it, some less because I've tested with them. How do I get these accounts? You can do it very easily going to Algo script in your Algorand design repo. And there is a script that I wrote that is named generate accounts. They do that for you. It generates 5 of them. If you go to the source, you can put whatever number suits yourself. Don't forget to have Node installed. So I'll check it. Version, okay, 16, fine. And I will run it node dot generated accounts. Oops, sorry for that space. Okay, it will generate 5 accounts for you, and if you don't want to copy and paste it from console, of course, you have a text. You have a text file that gives you this information for your pleasure to have. Okay, generated more than 5, it will happen to that file, so you don't lose previously generated accounts. Okay, since this is done, I will clear this script file. I will close it actually. What do we need to do? I'm already in Algorand clone repository. So if I less about my backend, my frontend, etc., I'll begin to run the backend. So to run the backend very easily, I explained it earlier. You cd to the backend and go run cmd may not go. Fine. It will run. We'll let it run. Shouldn't be too again. Don't forget to accept. On Mac it will be something like that. Okay, we now have our server in 1881. Simply to check it, we go to Swagger. So Swagger is in localhost 8081 happydocs-html.index. So here we see all the documentation for the endpoints. Check it out if you're interested. Next, I have my backend. I will let you run another terminal. I will go into different end and start the local server for React app. It may take a little longer, not too much. Okay, fine. We have our application here. The first step is to connect to the wallet and to grant it access. So connect to wallet. He didn't ask me for my password since I've already granted access earlier, but it should. I want access. So now that I have access, it will ask me to sign a transaction for a payment, sending nothing to an address. The address is the first address. I have test1, address of test1. So if anything happens, it should not do nothing. If you see details, you can see that it's totally empty. The backend only needs a signed transaction. It will verify that against its signature and nothing else. This proves that I really own this address. So I sign it. Okay, it asks me for my password, so I'll input it. Fine. Same for address 2. 3. 4. 5. And then the backend already trusts me that I have these 5 addresses in my wallet and I can sign with them. Okay, here we implement the M of N multisign. By default, 3 by 2. Okay, but that's not enough for us. We will have, I will say, 1, not 4, but 5. 5 of 1. 5 possible signals, 1 signature required. Okay. Addresses can be added from the wallet. You see, I have my 5 addresses that I signed with, nothing more and nothing less. For the sake of the demo, I will take all the addresses from my wallet, but as you can see, you can add other addresses in these 2 text fields. I will not do that for just to be quick with that. It can be done, no big deal. Once I have 5 addresses, I've give the application a threshold and it corresponds. I can go to generate a multi-sign address. The address is generated. It's that. Fine. Don't forget to give phones this address. Simply click copy multi-sign address and open the testnet dispenser. I use this testnet dispenser. It can be anything else. It already has some phones, but I will give it a little more. No problem. Oh, wait, I'm sorry about that. Fine. Uh, I will check it. Okay, I have one. Okay, I can see what an onion is, but television, no. Fine for me. Thank you, CAPTCHA, dispense, and you will have your transaction status. If you want to see it, simply go to testnet, okay, and watch it. It should have some phones. Okay, this not important. That's okay. Once it was funded, we can go to generate a raw transaction. Here I implemented two types of transaction, NFT or payment asset. With NFT, you just have to fill up all these text fields. I will not do it for brevity of this demo. I will get a payment. It's easier because we have less to write. Payment address, whatever you want. I will use that, another address for this transaction. Don't forget that the amount of algos you send to an address or to any transaction should be more than this amount. I will send, let's say, one algo. Okay, one algo, and we can do it. Yep, 6, fine, 1 million micro algos. You can fill the payment note, payment for you, whatever, for you, hey, you, from me, or whatever you want, invoice number or an announce, but whatever you want. You will have a transaction ID that will be passed to the back end. So I generate a raw transaction. It gives me a sum up with a raw transaction if you want to copy and paste it in other applications. Fine. Version 1, threshold 1, and accounts 1, 2, 3, 4, 5. Fine. That's what I wanted. I go to sign the transaction. Once we are here, we can see that the back end has done some things. Okay, we have here a cron job, hasn't found any transactions that was met, and the other calls. Please watch the information. Of course, here you have the information about the received transaction, which is row EID, can be useful for troubleshoot. Okay, I will take my first address, and I have some transactions from before. Okay, I will go to the last. And in the last transaction, I see with no signatures, this ID that is in the back end and possible signers are already that. And of M type 1 from 5 to from version 1 of MSIG. Okay, so if I sign it, which I will do, it will send one algo to this address with a fee of this. Doesn't matter too much. I will sign it. Pass it in. It is signed. So fine. I will quickly go again and see that the transaction is ready. Just ready because the back end, sorry, didn't yet broadcast it. So we will wait a little. Okay, it's broadcasting. We have info. Waiting for confirmation. It's confirmed. Once it's confirmed, okay, we'll see what's happening here. And the application give me the information that the application is broadcasted. I can open this link and the transaction ID, sender the multi-sign, receiver this, So if I click, I can see the funds were transferred for that. Uh, Check it. This is an FT because I already typed for another one, but if I go back, I can see from the receiver more easily that I got a transaction of 1 hour ago to my account 1 minute ago. Okay, fine. Now we'll try something with more than one signer. We are here. We generate a multi-sign address. I will generate a 4-3, for example. Can be a 4-2, whatever. Address is from the wallet, so I don't have to do anything else. Generate multi-sign address. This is the address. I copy the address. I go to the dispenser. I paste it. Key. Maybe it's 2. I don't know. One. Okay. Right. Good. I will check. Funds are in the wallet. In the address. Okay. I've already sent it some algos, but just check it. Fine. I'll generate. Instead of a payment asset, I will could do an NFT. Same thing. You can NFT asset name, NFT me. Unit name. Be careful. It's only 8 bytes. But if you access 8 bytes, you could the application has a safeguard for it. NFT me. Okay. You can put whatever website you want, URL, whatever node, manager, etc. The application ID is there. Okay, I generate a raw transaction and I will see it in the transaction, last one, and you see pending, no signatures yet. From the backend, we'll see we have these transactions and this information. Check it out. So we need 3 signatures for this to work. I will sign with my first account. Sign. Okay, was signed. I will sign it with my second. You see we're only 2 now, not 3. Good. If I watch it again, we'll see only 1 is remaining. If I choose an address which is not inside the transaction will not appear. So I can sign it. And of course, this one, I don't know, whatever. You can sign 2 or not. Yes, this is a transaction. In case of doubt, I'll see NFT me. Okay, fine. I signed it. And the process is exactly the same as before. Okay, signed. If I watch again, same transaction, because it's ready, not already broadcasted, and yes, it broadcast. Wait for confirmation, and then transaction is confirmed in block, whatever. So if I watch it again, last one, perfect. So it's broadcasted. I can go to Gold Seeker, see transaction details, and this address, which was the one who had sent the NFT, we'll have new asset, asset 2, NFT, me, last one here. Okay, the first one I've done for testing measures, no problem. Okay, NFT me. Now if I go to the creator, the latest you can see is asset configuration 1 NFT me 55 seconds. 1 minute ago. Okay, that's all for the demo. Of course, there is a live demo of all of this. If you check the README file, you can see it right there. Demo for the front end, demo for the back end. If you click the back end, same thing. You can try it already without setting up a local installation, a local setup. Next and last, the conclusion for my video. To conclude, many improvements have been made. In Algorand script, we now have added a script that generates 5 accounts on the testnet. This is useful for newcomers that don't know too much about the Algorand blockchain to quickly set up a test and test this application. In the user interface perspective, authorization has been made directly using AlgoSigner extension to sign wallet addresses and to ensure that the addresses are really belong to the user. Raw transactions are not directly generated inside the browser in the front end. I've given two examples: a Nifty asset creation and payment transaction asset. Addresses are taken directly from AlgoSigner wallet. No need to copy and paste anymore. And the front end now shows transaction information before signing a transaction. From the backend side, I've added N of M capabilities, include some, in these cases, mainly M of 1. I've added MC parameters to the database, so the user can directly query it from the backend. Also, a nice API documentation with a Swagger UI interface, so anyone can check it and work with it easily. Internally, the backend checks any raw transactions before they are added to the database, which adds some security from that standpoint. Also, we have a cross-site regress forgery protection via cross-site regress forgery token generated from the backend and send it to the front end. Also, a rate limiter for mitigating denial of service attacks. And of course, the GWT authorization token is generated inside the backend and sent to the front end for use. I've really enjoyed to work with Algorand SDKs. In this case, Go SDK and JavaScript SDK. There is a lot of variety of other languages supported by SDKs. Mainly, I don't know. I think it's Python, Java, and other languages. I've had fun doing so. It's very nice. Documentation is nice, and I hope everyone will use this technology in the future. Thank you and goodbye.